This lesson, 5.4, is about special parallelograms. Okay, the first special parallelogram is the well-known rectangle. And a rectangle is a parallelogram that's defined as having 4 right angles. Okay, and it has a special property. The special property of a rectangle is that if we take the diagonals, and we know already that the diagonals of the parallelogram bisect each other, not only that, if it's a rectangle, they are all the same length, every segment. The entire diagonal is the same length as the other one. So I can say that AC is equal to BD. So for all rectangles, the diagonals are completely congruent, not just bisecting each other, but the entire lengths are congruent. And there is a special way to know if you have a rectangle. All you need is one right angle in a parallelogram. If you have one right angle, because of the other properties of a parallelogram being opposite angles congruent, you know that you have a rectangle. So any one right angle in a four-sided figure, you know you've got a rectangle. The second special parallelogram is a rhombus. And a rhombus is defined as a parallelogram that has 4 congruent sides. So it's like a square that's just been tipped a little. And all 4 sides are congruent. Now, the special properties that a rhombus have to do with its diagonals, much like with a rectangle. So if I go with some purple diagonals this way, or maybe a purple one that way, and we'll go with a green one this way, there's 2 things that are true. First of all, the diagonals are perpendicular to each other, so we get 4 right angles there in the middle at their intersection of the 2 diagonals. And then the second special property is that the diagonals bisect the angles of the rhombus. So the interior angles of the rhombus itself are bisected. So for these angles here, these 2 will be the same measure as each other, and as these 2, because the whole opposite angles are congruent. And then these 2 angles will be congruent to each other and congruent to the 2 that make up the adjacent angles here that make up the opposite angles of that. So those diagonals are bisected. Now, how do you know for sure if it's a rhombus, if you're looking at a 4-sided figure and it's a parallelogram? You know it's a rhombus if any 2 consecutive sides are congruent. So if you just have 2 sides next to each other, then you know they all must be congruent because it's also a parallelogram, so opposite sides will be congruent. So any 2 consecutive sides congruent. So like if I have a situation where I've got this one and this one congruent and it's a parallelogram, then I know I've got a rhombus. Okay, the third special parallelogram is a square. And a square is a merger of a rectangle and a rhombus. It has both properties. First of all, like the rectangle, the square has 4 right angles. And like the rhombus, the square has 4 congruent sides. So we can kind of think of a square as a rhombtangle. Okay, it has the attributes of both both the rectangle and the rhombus. Okay, here's a miscellaneous theorem thrown into this lesson, and it has to do with diagonals of a rectangle. But it turns out that if the midpoint of the hypotenuse of a right triangle, so we've got a midpoint right here, if that happens to be equidistant from the 3 vertices. Well, we can already see that it's equidistant from this vertex and this vertex, but it also is equidistant from that right angle. So those 3 segments all have the same length. This one, and this one. And you know, the reason that makes sense is that if you fill out the rest of the rectangle here, you can see that those would be like the diagonals of a rectangle bisecting each other and being all the same length. So anyway, that's a theorem that we'll be using. Okay, so in this first example we have a rhombus, and we're told that this that angle 1 in this rhombus is 25 degrees. So I know, because the diagonals of a rhombus bisect each of the angles, that angle 1 and angle 2 are the same measure, so angle 2 must be 25 degrees. Now I know that the sum of those two angles is 50 degrees, and because this rhombus is a type of parallelogram, that this big angle has to be supplementary with angle 3 and 4. So I know that angle 3 and 4 have to together equal 130 degrees. So angle 3 has to be 1/2 of 130 degrees, which is 65 degrees. And angle 4 has to be the same thing. And then angle 5 down here in the middle, well, I know that diagonals of a rhombus intersect at 90-degree angles, so that angle 5 has to be 90 degrees. Okay, and let's suppose I know that angle 1 is equal to a value represented by the expression 3x plus 8, and angle 2 is the value represented by 11x minus 24. If I'm asked to find x, I just have to equate those, because I know that measure of angle 1 is equal to the measure of angle 2, because I know that that angle has been bisected. So I know that 3x plus 8 must be equal to 11x minus 24. So if I subtract 3x from both sides and add 24 to both sides, I get 8x is 32, so I know that x must be equal to 4, and I can check that back. Both angles equal 20. Okay, in the last example with rhombuses, if I know the measure of angle 1 is equal to 3x plus 1, and angle 3 is equal to 7x minus 11, well, let's do a little work here. I know that angle 1 and angle 2 are the same measure. So I could look at this as being that angle 2 is the same as angle 1. So angle 2 is 3x plus 1, and angle 3 is 7x minus 11. And I also know that this is a right angle here. So I know that angle 2 and angle 3 together have to equal 90. So I can write a little equation to say I know that then that 3x plus 1, 3x plus 1 plus 7x minus 11. So this is measure of angle 2, which is the same as angle 1, and measure of angle 3 are complementary to each other. They have to add to 90. Or I could use all three angles, include the right angle, and say they have to add to 180. So anyway, I get 10x minus 10 is 90. So x is equal, 10x is equal to 100. So x is equal to 10, making angle 1 31 and making angle 3 69 degrees. Or, I'm sorry, 59 degrees. So this little video is getting a little long, so I'm going to continue in part 2 with a few more examples with rectangles and the right triangle theorems, and that'll be it. So see you back for the second part of the lesson.